Explanation has been a different thing, recommended as the hypothesis of the old. Boundless impact and different appraisals, besides made by countless scientists, support this thought, giving certification about how the universe started. In any case, the current universe of science, with new headways, brings us novel assessments and perspectives. These thoughts challenge our places of view, where certain pieces of data, such as those from Neil deGrasse Tyson, have turned into a colossal figure in this influencing universe of science. Now, something drawing in is happening with the James Webb Space Telescope. It's essential to recognize something that could make us question the hypothesis of the universe's starting. The James Webb Space Telescope has found 750 new universes. These frameworks are not exactly identical to what we expected, and they lead us to rethink what we assumed we had some awareness of them. This degree should assist us with appreciating how enormous frameworks turned out to be. So, it's not astonishing that it's working up how we would have the option to disentangle the universe. Before, specialists said that the Big Bang hypothesis was an exceptional explanation for how the universe started. As per this hypothesis, around 13.8 billion years ago, the universe showed up through a confounding occasion, like the crazy story of the universe's introduction to the world. Anyway, the photos from the James Webb Space Telescope have tested this thought. These photos show universes that are more subtle, smoother, and older, to say the least, and not quite the same as what the hypothesis of how things came to be predicts. As per the speculation, as the universe extends, objects ought to look more observable the farther away they are. Nevertheless, these self-absorbed structures try not to keep that standard. The hypothesis also states that, at the universe's genuine beginning, all the matter that makes up the universe was squeezed into a second superdense point called a singularity. This singularity was unfathomably hotter than anything we could really measure or make. This idea of a singularity comes from a lot of conditions in genuine science, proposed by Albert Einstein, called general relativity. Inside the singularity, all the stuff in the universe was pressed into a minuscule space with exceptionally high density. It was a colossal measure of mass and energy pressed into a small space. In easier terms, specialists have continuously said that the hypothesis of how things came to be was how the universe began. Anyway, these new pictures from the James Webb Space Telescope are making us question that thought. The universes it found don't fit with what the hypothesis expected, and the hypothesis explanation of the early universe probably won't be as strong as we once thought. In our persistent perspective on the universe, we perceive that all the energy in the universe started from a very hot and thick point called a singularity. This point is like the early stage for all that we view as in the universe today. After this singularity, the universe began to grow and create over roughly 13.7 billion years to become what it is today. The extension started with something many refer to as the Great Expansion, where the universe became incredibly rapidly, much faster than the speed of light. Maybe the genuine surface of space itself was extending, and everything in it was extending alongside it. This limitless development helped shape the universe by making things more uniform, furthermore, making a way for universes, stars, and other influence plans to shape. As the universe continued to develop, it didn't extend as fast as during the Great Expansion. Anyway, it still continued to grow. We call this steady extension gradual headway. Specialists have seen proof of this increase through things like the way light from faraway universes changes in variety, known as redshift. Presently, let's look at those shocking pictures of new universes taken by the James Webb Space Telescope. To the larger part, these photographs look stunning, with different universes in a single frame. Anyway, for inspectors, it's generally a shock. These photos don't match what their theories expected. As an issue of some significance, these universes are basically more advanced than anticipated, which challenges our perspective regarding framework structure and advancement. As indicated by the hypothesis of the old Big Bang, there are besides altogether more vast frameworks than we expected. The hypothesis of the universe's start made surmises about the number of frameworks there should be and the way that they should be spread out. Anyway, the JWST pictures show a colossal number of universes, some more than expected. This makes specialists question whether the hypothesis gauges are accurate. A few scientists are even starting to overcompensate a bit, considering the way these discoveries really don't coordinate their thoughts in any capacity. One more astounding piece of these new self-important designs is their flawlessness, which clashes with what the hypothesis of how things came to be proposed. As per the hypothesis, universes should show anomalies and patterns in their designs due to how they formed and grew. Yet photos from the JWST show universes that are incredibly smooth, without the standard complexity and viciousness during the movement of the universe. All that makes up our universe was squeezed into a little space. As the universe extended and cooled, changes occurred in particles like protons, neutrons, and electrons, which started to interact with light and energy around them. These connections assumed a colossal part in the improvement of matter in the universe. In the initial 2 or 3 minutes after the Big Bang, there was a process called nucleosynthesis, which involved the production of lightweight components like hydrogen and helium. These components set the stage for the arrangement of stars, innumerable frameworks, and more complex components as unending history unfolded. This blend of essential building blocks was a critical stage in the universe's advancement, progressing from a beginning condition of particles and energy to a state where matter began to form. True to form, the hypothesis of the old Big Bang had expected to see universes that were cluttered and tumultuous. Anyway, the JWST pictures tell a different story. Instead of rough and dissipated universes, the photographs reveal smooth, round, and fit winding shapes, looking like the frameworks we find in the ongoing day universe. This surprising revelation challenges the thought that confusion is a commonplace piece of universe advancement. Assuming that there are few or no tumultuous events happening in these universes, as proposed by the hypothesis of how things came to be, it becomes nonsensical that small universes would be able to develop and turn out to be more significant. Additionally, the optical intriguing quality anticipated by the expanding universe speculation, where objects seem more modest with increasing distance due to development, doesn't seem to be present in space. Specialists have noticed a striking example where gigantic designs tend to group together in enormous social gatherings, forming various organizations across the universe. This enormous-scale structure lines up with the suspicions made by the hypothesis of the universe's start. As indicated by the hypothesis, the universe started in an incredibly hot and thick state and then extended and cooled over time. As the universe extended, gravity played a key role in shaping how matter was distributed and in organizing universes. The gravitational effects anticipated by the hypothesis of the old Big Bang are consistent with what we see today, with gravity arranging matter, prompting the grouping of cosmic frameworks and the development of interconnected filamentary structures known as the cosmic web. The presence of these framework groupings and the enormous web structure strongly supports the hypothesis of the ancient astronomical explosion. How frameworks are dispersed across the universe aligns with the gravitational effects anticipated from an initially dense and expanding state, as proposed by the hypothesis. These factors, including the grouping of frameworks, the vast web structure, and the spreading of universe groups, provide strong proof that the universe evolved from an incredibly dense state and has been expanding for billions of years. Now, let's return to the size of the designs viewed by the JWST. These photographs go against what we thought we knew about the Big Bang hypothesis. As indicated by the hypothesis, small universes should form and stretch through impacts and consolidations with other universes. Anyway, the universes made by the JWST feel very different from this thought. If cosmic designs were impacting and converging as anticipated, we would see proof of these impacts or consolidations. But the photos show something else. The Big Bang is, after all, a remarkable hypothesis, basically a thought without definitive verification. Now, it is truly backed by undeniable proof, including perspectives on the redshift of light. Observations from far-off universes offer support for the expanding universe speculation. Studies showing universes expanding their distance from each other propose the expected steady increase anticipated by the hypothesis. The spread of light elements like hydrogen and helium seen throughout the universe is also consistent with the hypothesis of the universe's start. Furthermore, the large-scale dispersion of universes, as revealed through galactic outlines, matches the patterns anticipated by the theory of how things came to be. One of the fundamental bits of evidence for the Big Bang hypothesis is the discovery of the cosmic microwave background, CMB. The CMB is faint radiation that fills the whole universe and represents the remainder shine of the Big Bang. This enormous radiation, previously recognized in 1965, still lines up with the predictions made by the hypothesis of the universe's starting. The observed qualities of the CMB, its consistency, and temperature distribution strongly support the likelihood that the universe was once in an extremely hot and dense state before going through expansion, a central piece of the hypothesis of how things came to be. The discovery of the cosmic microwave background is a crucial piece of evidence that gives us a unique look into the early moments of the universe. It acts as a remnant of the first stages after the Big Bang and plays a fundamental role in establishing the theory of the universe's origin as our best explanation for the earliest stages of the universe's development. Revelations have tested several aspects of the Big Bang hypothesis. The presence of universes with ages that seem to start too early raises intriguing questions and suggests that our current models may require adjustments. If we continue to see discoveries that go beyond the expectations made by these theories, we may be forced to refine or rethink our understanding of the cosmos's history. As we delve deeper into these discoveries, we also recognize that science is always evolving. The ongoing advancements in technology, like the James Webb Space Telescope, have provided us with new insights that challenge old ideas. These revelations aren't just about finding new evidence. They're about pushing the boundaries of what we thought was possible, even questioning the established frameworks of our universe's birth and evolution. The existence of early galaxies that don't align with the expectations of the Big Bang theory opens up new possibilities. Perhaps the universe began in a different way, one that we have yet to fully understand. Could there have been other forces or mechanisms at play during the universe's early stages? The anomalies observed by the JWST might indicate that our understanding of cosmic evolution is incomplete, prompting us to rethink the timeline and processes that shaped the universe. We may need to explore entirely new theories that incorporate these unexpected findings. For instance, some researchers are beginning to consider ideas that merge elements of the Big Bang theory with concepts from other fields, such as quantum mechanics or theories of multiverses. These alternative ideas might offer explanations for the complexities observed in early galaxies, bridging the gap between what we thought we knew and what we're discovering now. Moreover, while these discoveries cast doubt on the traditional Big Bang model, they don't completely invalidate it. The Big Bang theory still offers compelling evidence about the expansion of the universe, the cosmic microwave background radiation, and the distribution of elements in the universe. It may be that the truth lies somewhere between the current framework and the new insights we are uncovering. The hypothesis of the Big Bang may evolve into a more nuanced theory, one that incorporates the surprises and unknowns that the James Webb Space Telescope has illuminated. As we continue to push the limits of space exploration, it's crucial to remain open to new interpretations. Each discovery adds a new piece to the puzzle, and though it may not always fit perfectly with the pieces we already have, it brings us closer to a fuller picture of the universe's origins. The road to understanding the universe's beginnings is long and complex, but the pursuit of knowledge, no matter how it challenges existing theories, will lead us to a deeper appreciation of the cosmos and our place within it.